Yeah, hello. Anybody please confirm. Am I audible?
Yes.
Yeah,
Yes,
okay.
Prashant.
Okay. So we will start from week 9. So you got the concepts of to week 8, right? Yes, so is my screen visible to all of you?
Yes.
So I have collected some question collections, so which have covered the syllabus of week 9 and week 10. You know what is the meaning of random variable? Hello.
Yes.
Yeah. Okay, so this is the question which is related to the something random variable. So question is nothing but range of a random variable x is the set of all possible values that x can take. Okay, so this is something about range of a random variable. Okay, range of a random variable is what? Is nothing but the set of all possible values that the random variable can take. Now, question is let a random variable y be defined as the number of tosses until first head comes on the tossing a coin. Then what will be the range of y? So read this and try to think about the answer. What should be the answer, correct answer for this question?
I think it is C 1, 2, 3.
1, 2, 3. Okay. Anybody else?
Yes. 1, 2, 3. Because the random variable x and the range will start from 1, 2, 3 when we toss the coin.
Okay.
Option
Anybody
D.
else?
It should be D.
Okay, someone is saying option D as well. So let two votes for option D, one vote for the option C. Okay. Anything? Anybody else?
It should be option C.
Option C, two votes for option C as well.
D, sir.
D. Okay. Majority is going with option D. Yeah, please be focused on the what is your y random. What is your random variable y? Is defined as the number of tosses until first hit comes. Okay. On tossing a coin. Okay. So yeah, please tell me. Three votes for option D and two votes for option C. Anybody else? Okay. See, correct is the option C. Why? What is your random variable? See, what is the range? Range is nothing but the set of all possible values that x can take, right? So y is what? Is number of tosses until first head comes. So even for finding a single head, you need at least one toss, right? Suppose you toss a coin and you got head, right? This can be possible. Other way can be you toss coin, you got tail, then you again toss coin, then you got head. Okay, then you have to stop. This why is the what? Nothing but number of tosses until the first head comes. So here I need one toss for first head. Here I need the two toss for first head. Similarly, it can be like this. TTS, that means three toss, four toss, and so on. So it will not take value the as 0. So correct option is will be SC. Is this clear?
Yes.
Yeah. Is it clear for everyone? Yeah. Right. So you know what is the random variable? Random variable is what? Is nothing but you can see when a probability experiment is performed. So in general, we are not interested in all the details of experimental result. Okay, but we are interested in some in the value of some numerical quantity, right? Like see, or you know what is the random variable? Random variable is what? Nothing but the you can define as the real valued function. Okay, uh, on the sample space kind of things. Okay. So suppose x is a random variable, then values of x can vary, right? So it can be anything, right? Suppose you roll a dice 2 times, right? Suppose you roll a dice 2 times, okay? Then what can be random variable? Like x can be random variable, like sum of on both dices come out to be 6, okay? So x will take value your 1 5 2 4 3 3 again 4 2 and 5 1 and so on. So here x is your random variable. Here our probability experiment is performed, but we are not interested in all, but any one we are interested, like x. We are interested here in finding the sum of on both the dices. Okay. So is it clear now about the random variable?
Yes.
Yeah. Okay. So uh, yes, you know what is the, see, random variable has 2 types. One is discrete random variable, another one is continuous random variable. Okay. So you are aware about discrete random variable and continuous random variable?
Sir, continuous is the one which is measurable at a decimal
Yes.
level, like
Yes.
height, weight, and all.
Yes. Continuous
And
random
discrete-
variable is nothing but where you cannot count, but you can do measurement, right? And it can take any values on a real number line between a given interval. Okay. Discrete random variable is nothing but which you can count. Okay? You can count the things, and if you plot on real number line, then discrete random variable can take distinct values on a real number line. Is it clear about discrete? In continuous, we cannot count the thing, but we can measure. I mean, measurement concept is involved for the continuous random variable rather than counting, because in discrete random variable, count is involved there. Is it okay?
Yes.
Yeah. So this is the next question is based on the about continuous and discrete random variable. So read it and tell me the what should be the correct options for them.
X is a continuous
X
variable.
continuous, Y discrete.
Okay, one vote for option A and one vote for the option D. Right?
Sir, option A.
Only option A.
Yes.
Okay, let me change my color.
And D as well. D is discrete. Y is discrete.
Okay, Rupal is saying option A and Naresh is saying option A and option D as well. Okay.
A and D, sir.
Both A and
First,
D.
okay, A and D. Anybody else? A and D. Okay. So
A and
major,
D.
yeah.
A and D.
Okay, majority are going with the option A and D. Yes, the option A and D are the correct option, because what is your x is here? X is nothing but the error in the measurement of length, right? Just a few minutes before we have discussed what is the continuous. If measurement concept is involved, then variable will be continuous, right? And it, if you plot the values on a real number line, then it can take any values on between a given interval, right? So length of So measurement of length we can do in meter, centimeter, and whatever. Okay. So here we cannot count the length. We have to measure length in meter or centimeter, whatever. So that's why your x is a continuous random variable, not discrete random variable. Okay. So option A is the correct, and option B should be obviously wrong. So let consider about y. Y is what? Number of imperfection per 10 meters, right? So here you have to count the imperfection. You are not measuring the imperfection, right? So here we are counting the imperfection. So it can take also distinct value on real number line. Like it can happen like one imperfection, two imperfection, three imperfection, and so on, right? So here counting is involved. So y will be the discrete random variable, which is the correct option. Is it clear for everyone?
Yes, sir.
So basically what we are saying is if a variable takes a real value, then
Yeah.
it's continuous. If it takes a integer value or maybe the whole number or natural number, it's basically a discrete variable.
Actually, Naresh, what is this? It's not about decimal and all things. It's about if you can count and it is taking the distinct value on real number line. It might be possible for some example like 1, 1.5 to 2.5, some
Okay.
anything. If it's taking only value like 1, 1.5, 2, and 2.5, then you can consider
Mm.
it as discrete. Suppose, see, you have only these four,
Okay.
okay? So you can count it,
Okay.
right? And it can take distinct value on real number line as well, okay? So it's not
Yeah,
about
yeah,
decimal.
good.
Yeah, but the simple trick you can remember, it can take any value like 1.53729. Then you can consider it as a continuous because it is taking
Okay.
any values, right? Right?
Yeah, got your point. Got your point.
Yeah. Yeah, just a simple basic difference is you have to see whether you are measuring the things or counting the things. Okay. So tell me about, let's say I'm saying about, tell me about speed of a car. What it will be? Continuous random variable or discrete random variable?
It's continuous.
Why
Continuous.
continuous? Why continuous?
Speed increases and
Because car is traveling
Yes,
for a
because
distance.
speed is something which we cannot count. We have to measure. We can measure speed in kilometer per hour, right? Right? It's not about counting the speed. No, it's about you have to measure the speed, right? We are not generally measuring the speed in kilometer per hour and all, right? So whenever measurement is involved there and it can take any value between a given interval, then it will be the continuous. Is that clear?
I think this is the perfect thing. We just can check whether it's a measurable quantity or it's a
Yes,
counting
yes.
quantity, right?
Counting quantity. Yes, yes, yes. If it's a counting, then this it will be discrete. Otherwise,
Yeah.
so is it clear for everyone?
Yes.
Okay. So yeah, let me move for the option A, and option D was the correct answer. Okay, again there is there is an example of about you have to find the difference between, I mean, which one is the discrete? I mean, what are the discrete random variables? So tell me about which should be the correct option.
Number of customers visiting
B,
every
D.
hour in the shop.
B
D.
and
D.
yes. Okay.
Number of accidents. Yes.
Okay. Anybody else?
B and D.
Why not about length of the phone call?
So time bound no.
Time increases like
Because
Between 7 and 8 minutes, you can have 7.34.
Yes, yes. Because length of a phone call, it can take any value, right? 1 hour, 30 minutes, 2 seconds, some nanoseconds and all things, right? Okay.
Yes.
Yeah, number of customers you can count. Yeah, 1 customer, 2 customer, 10 customers, 15 customers are visiting every shop in the sorry, are visiting every hour in the shop, right? And amount of milk you have to measure in liter and all, 1 liter milk, 2 liter milk, something, right? Now, number of accident you can count, right? On NS10, like every hour there is you can say on an average 2 accidents, something. That means you can count that number of accidents, right? And it can take a distinct value on real number, like right, 2 accident, 3 accident, 4 accidents. Okay, travel time again it will be continuous, right? So B and D is the correct option. So is it clear? I mean, concept about discrete, continuous, random variables is clear for everyone?
Yes, sir.
Okay. So let's move for the next question.
Yes.
You are aware about the PMF, right?
Yes.
Okay. So this is the question
No.
based with no. You are not aware about PMF?
Probability mass function.
You can
Yeah,
just like
PMF is nothing but probability mass
probabilities.
function.
Yeah, yeah.
Okay.
Okay.
Okay, probability mass function is what? Suppose your x is a random variable. Okay, it's suppose hypothetically let's assume it is taking n values, right? Then what is the probability mass function shows you? The probability of each values of x. That means probabilistic behavior of each values of the x. Means what is the probability for value of x1? Okay, let's assume p1. What is the probability for x2? Let's assume p2. And what is the probability for xn? Let's assume the p. And this is the something probability mass function. And there is two important property for the PMF. What is that? First one, all the
Sum of-
probability. Yes. Yes, Rina, sir. Hello. Hello. Okay. So there is property for satisfying the which to satisfy the property for the PMF. First property is all the probability should be lies between 0 and 1. Okay. First property. Second property is there. Sum of all probabilities should be equal to 1. That means uh, P1 plus P2 plus Pn should be equal to 1. And if all the probabilities is between 0 and 1, then it will be the PMF, right? Probability mass function of a random. Is it clear?
Yes.
Okay.
Yes.
Yeah.
Yes.
So question is nothing but the random variable x. I mean, this takes the value 1, 2, 3, 4, and 5, and there is a below is the table which gives the PMF for x. So you have to find the probability of x equal to 5. Okay. So this is the question which is I mean you have to calculate the probability x equal to 5. So this is the question. Okay, and these are the options. So you have to compute. Question is you have to compute the probability of x equal to 5. So this is the question. Okay. So do it. I think 3 minutes will be more than enough, right, for this question. Okay. So please do it after 2 to 3 minutes. We will discuss it. Okay.
P equal to 1/4. Yeah, so the probability of 5 is equal to 3/8. Yes, 3/8.
3 by 8.
One by 8.
Three by 8.
Okay, so 3 by 8 for everyone. Okay, so tell me, what was your approach? I mean, what should be the first step?
Sum total should be equal to 1.
Yes, if you see in the probabilities, there is a constant which is t, right? So before calculating probability at x equal to 5, we need to find the value of t. Okay, so by the axiom of PMF, property of PMF, you know sum of all the probabilities in the should be equal to 1, right? So that means 0 plus t by 2 plus 4t square plus 3t by 2 should be equal to 1, right? So what I think it will be 4t square plus it will be 4t by 2, right? That means 2t, t plus 2t equal to 1, right? So it will be 40 square plus 3 times t minus 1 equal to 0. That means next it will be 40 square plus 2t plus t. No, 1 second.
Plus 3t plus t.
Yeah, plus 3. No, 1 second. So 40 square.
Plus 40 minus t.
Yes. This is 40 square plus 40 minus t minus 1 equal to 0, right? So here 40 I can take as a common. So it will be t minus 4, t minus 1, minus 1 I can take common. It will be t, it will be t plus 1, it will be t plus 1, right? So it will be 40 minus 1, t plus 1 equal to 0. So here we have t equal to minus 1 and t equal to 1 by 4. So we cannot t as a minus 1. Okay, why? Because if you will take t as a minus 1, your probability will become negative, okay, which is not possible. So you have to take value of t as a 1 by 4, right? So now okay, so here I can put the value of t as 1 by, so here is 0, it's 1 by 4. Oh, sorry, 1 by 4. So it will be 1 by 8. It will be 1 by, 4 by 16, right? So it will be 3 by 8, right? So probability at x equal to 5 will be 3 by. Is it clear for everyone? Yes. Yeah, hello. Is it clear for everyone?
Yes.
Okay. So how? Okay. Suppose any question is related to give. Any question is given related to PMS, so you will be able to solve this, right? It's nothing about just it can
Yes.
have question is can be the suppose question is about what is the probability of okay, so tell me what should be the probability of this. So what will be the correct answer?
Px equal to 3 plus Px of equal to 4.
Yes. Okay, because it's something discrete value. Yeah, here we have to find the probabilities of x lies between 2 and 5. So we have 3 and 4 only. Okay, so you have to come add the probabilities this and this. Okay.
I
Is
have a
it clear for
question,
you?
Prashant.
Yeah, yes, please.
In while we are solving for distance equations, if the answer turns out to be negative, we would automatically say distance cannot be negative, so we'll make it a positive value and take it. The same way we can apply for probability also, no? It cannot be
Yes,
negative,
yes.
so yeah.
Yes,
Okay.
because all the probabilities, see, probabilities should be always lies between. It should be minimum value should be 0 and maximum value should be 1. Okay.
Yes.
Probability value of probability cannot go beyond 1 and cannot take value less than 0. Right.
Yes.
And this is the first property. Second property is you have to satisfy summation of all the probabilities should be equal to. So these are the two basic property of the PMF, right?
Yes.
Okay. Okay, you know what is the CDF, cumulative distribution function of random variable? See, in this in the just previous example, we have seen, okay, we have computed the probability at a particular point, right? That means P at P probability at x equal to 5, right? So what is the need? What is the meaning of CDF? Okay. So CDF is what? Suppose f of a is nothing but the probability of x is less or equal to a. Okay.
Yeah.
So cumulative distribution function is basically accumulates the all the probabilities before this point, right? I mean up to this point. Okay. Suppose I'm saying f of 4. That means you have to find the probability less than equal to 4. Okay. So CDF accumulates the probabilities up to the given point, right? Okay. Is it clear about the CDF? What is the meaning of CDF?
Yes.
Cumulative distribution function. Okay. Okay. And you know how you can compute the CDF and CDF to PMF or PMF to CDF? Are you aware about that?
Yeah, Prashant.
No, sir. No,
This
sir.
is
Please,
clear.
please explain, sir. No, sir.
The reverse.
Yeah, yes, please.
Yeah. No, from whatever you said, probability until certain point we cumulate and we determine the cumulative distribution function.
Yes.
How do we
Yes.
calculate the other way around? That you can explain, please.
Okay. See. Can you tell me the all this value? This is 0 and this was I think 1 by 4. This was 1 by 8, right? And this was 4 by 16, right? And this was 3 by 8. Okay. These okay. So these were the values. Okay. If you see, so what is the CDF? CDF is nothing but suppose I have to find the f of a. Okay. So how I can compute? So you have to consider all the points. Okay. So first value is 1. Okay. So you have to consider before x is less than 1, right? So can you tell me what is the value? What should be the value of f of a? I mean, before x is less than 1. Let's take it as a small x. I mean, before 1, what will be the value of x? You can
0.
yeah, you can
0.
visualize the graph, CDF graph, right? Okay, before minimum it's 0 and something, right? Okay, so it's a 0, right? Tell me between 1 and 2.
1 by 4.
It's again 0.
Again 0.
No,
Because
2
here
is not included.
yes, because I'm including only the 1. Okay,
Right,
so
2 is
at
not included,
1,
so it should
see
again
what
be
is the
0.
meaning of here? Yeah, what is the meaning of here? That means f of 1, that means probability x is less or equal to 1, right? So less, that means probability x is less than 1 plus probability x equal to 1, right? So x is less than 1 is what? 0 plus x equal to 1 is 0, that means 0. Is it clear? So it will be again 0. Now here 2, in the next step we have to include the 2 and before 3, right? So what will be the probability? That means here we need to find the f of 2. That means probability x is less or equal to 2 That means probability x equal to 1 plus probability x equal to 2. So what will it will be 1 by
4.
So I have a
right?
question, sir.
Yeah, yes, please.
So why did we, in the first two steps, why did we write it like two separate steps? We could have just written x less than 2 equals to 0, right? Why did we say 0, the probability of x less than 1 is 0,
Okay,
and then
Amit,
again 100?
Amit, what is the Amit, what is the criteria for finding the CDF is you have to consider the less than values for the first value of the your random variable and greater than for the last value.
Oh, the
Okay.
first value,
Yeah.
okay, sorry, I didn't see
Okay.
that. Okay, it is x
Yeah.
x equals to 1. Yeah,
First
that's
value
right.
of x is 1. Okay. So you have to
Uh-huh.
consider the before x is less than 1 and after this. Okay. CDF is what? You know, this is something up the first value is about 0 and at a point it will be up to 1, right? This is something
Yeah,
graph
I
of
mean,
CDF. Yeah.
it makes sense. I think I could not see the first
Yeah.
value of the random variable was 1. So okay, all right, that makes sense. Thank you.
So yeah, thank you. So what will be the value of before for this range? That means here I need to find the f of 3. That means probability of x is less or equal to 3 means probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. That means this probability plus this probability plus this probability, right? So what it will be? It will be 2 by 8. So it will be 3 by 8, right? Now, is it clear? Is it clear for everyone?
Yep.
Yes.
Yeah. So what will the this? What will the value for this range? Sixteen, 8 by no, it will be 2 by 16. So it will be 10 by 16, right? That means 5 by 8, right? Now we have to find the value probability x greater or equal to 5. Okay. So what it will be? 5 by 8 plus 3 by 8, that means 8 by 8, which will be 1. Okay. So this is something, this is the criteria. This is the method to compute the CDF. Okay. Is it clear? Suppose CDF is given to you, then how can you compute the PMF, right? In CDF, we have, we did the, we add the probabilities, right? So in the PMF, we will do the reverse thing. That means, so tell me, what will be the probability of x equal to 1 by this, these things? Don't see these values. Okay. So by this thing, tell me, what will be the value of x equal to 1?
So the thing is, you need to look at f of 2.
No, not f of 2. You have to look at up to equal to, right? And you
Yeah.
have to subtract the value this to this, right?
Yeah.
So it will be 0.
Yes.
So tell me probability of x equal to 2.
1 by 4 minus
1
0.
by 4
1
minus
by 4 minus 0.
0.
Yes.
That means 1 by probability x equal to 3.
3 by
1 by
8 minus
this value. 3 by 8 minus 1 by 4. That means
1 by
1 by
4.
8.
1
1
by
by
8.
4.
Okay. So similarly, you can compute, you can proceed further. Is it clear? Yeah, no. Okay. So for the next question, which is based
Sir,
on
can you explain the step again once?
which one?
No, how do you go just setting one from the other? Sorry, I just missed that.
Yeah, you got the concept about the CDF, right?
Yes, yes.
Okay. So in CDF, we are adding the probabilities, right? So for
Right.
calculating the PMF, we have to do the reverse thing. That's it. So add probability x equal to 1 is what? 1 is here, right? So before for probability x equal to 1, we have to do the this value minus this value, right? That means 0 minus 0 equal to 0. So for probability x equal to 2, you have to do 1 by 4 minus 0. Okay. So for x equal to 3, you have to do 3 by 8 minus 1. Okay.
Yeah, got it. Yeah, thank you.
So next question is this one. Okay. So I think yes. So you have to given the CDF and you have to find the probabilities that there are 3 defective items in the shipment of 10 items. Okay, that means what? You have to find the probability of x equal to
3.
right. So please compute that. What will be the correct answer? Okay, yeah, please do this. Do that. I will come back in 2 minutes. Okay.
0.09.
0.09.
Okay.
It should be 0.09.
0 point. Okay, how did you compute this?
1 minus 0.91.
1 minus.
0.91.
Okay. Anybody else? Okay. Rest of the people, please calculate this. I will come back in the 2 minutes. Okay.
Sir, it is 0.09.
It's 0.09. Okay. Anybody else?
Yeah, 0.09.
Okay. So 0.09 is the correct answer for this question. Okay. So you got the concept how to compute the probability mass function, right? Suppose see here we are interested in the only in finding the probability at a single value of the x. So if you have to compute the suppose PMF probability mass function for all the values of random variable x. So what will be the values of x? It will be 0, 1, 2 and 3. Okay. So what will the probability of x? It will be 0.041.
0.41.
At x,
0.41.
okay, at x equal to 1, it will be 0.78 minus 0.41. Okay. At x equal to 2, it will be this things.
0.12.
Okay, and 0.0. And if you add all these probabilities, it should be equal to 1. Right? Then it will be. So I think concepts of week 9 is covered, right? It's nothing but random variable, discrete random variable, continuous random variable, and probability mass function, and cumulative distribution function, right?
Yes.
If any question related to these topics will come, then I hope you will be able to solve this, right?
Yes.
Okay. So now come to the week 10. In week 10, if you have covered the lecture video, then ma'am has explained something, expectation of random variable. Okay. So expectation of random variable is nothing but the long run average. If you have remembered the lecture of the definition of the random variable, which is explained by the. So expectation of x is nothing but the long run average. Okay. Of long run average value of the random variable in the repeated independent trials. That means you have some trials and you are and all suppose you roll a die. Okay, roll a die 2 times, right? So rolling in the first trial, okay, when I roll a die at the first time, so roll outcome getting in the first trial will be independent from the outcome will getting in the second time, right? So that is the meaning of independent. Okay. So this is the something expectation of x. So expectation of x is nothing but the product of all the values of xi into corresponding probabilities, and you have to add all the probabilities. You have to add all the quantity, right? Hope you are getting the concept, right? Suppose you roll a die, okay, then what you will get? Outcome 1, 2, 3, 4, 5, 6, right? So what will be the expectation of x here? Okay, that means expectation of x is 1 into probability of x, I mean getting 1 is what?
1 by 6.
So roll a die, then probability of getting outcome as 1, what will the probability?
1 by 6.
Okay, so for it will be 1 by 6 plus next value of 2 into again 1 by 6. I mean for each value, I mean for each outcome you have the probability as 1 by 6. Okay, so 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. If you add, it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. Answer will be, I think, 11, 11, 4, 15, 3, 15 to 20, 21 by 6. It will be 3.5, right? So here you have computed the expectation of x for a outcome for the rolling die, right? So expectation is coming out to be 3.5. So what is the meaning of this 3.5? Does this mean that if you roll a die once, then should we expect the outcome to be 3.5? This is the meaning?
The average
No,
outcome
average
is
of
3.5.
this
No,
in the long run.
that is not a meaning. Expected value of x means when, I mean, we can expect as a average of a large number of rows. Okay, when you roll a die large number of times and you will take, I mean, then you can expect the average value should be 3.5. That's why expectation of x is called the long run average. Okay, so you are I mean, now it's clear how to compute the expectation. It's nothing but the values of xi into probability of xi. Is that clear? Okay, so tell me, if so can you tell me by seeing this table, what is the x? What is the x follow? Which distribution x is follow?
Uniform distribution.
Uniform distribution. Okay,
Yes.
why uniform? What is the
Because
meaning of uniform distribution? Because
probabilities
for
of
each value of x, we have the
same
constant
value.
probability. I mean same probability, right? Then your x will follow the uniform. This is something called the discrete uniform distribution. Okay, yeah. So yeah, please attempt this. This is the question. Okay, please read the question. In the question, you are given the expectation of uniform distribution, whose PMF is given to you in this table. Okay, so we are given the expectation. See, question, if the expectation of uniform distribution is given as 10, then what will be the value of? So please apply the concept of the expectation of a random variable, and after that find the value of it. Is that clear? Okay, I mean, are you able to solve this, right?
19.
Okay, so please do this. We will see after 2 minutes. Okay.
Nineteen. And it's 19.
Hello. Hello.
Yes, sir.
Yeah. Okay. So you got the answer?
Yes, sir.
Okay. What is the answer?
Sir, 19.
Okay. So let me see. Yes, 19 is the correct answer. Okay. So how did you compute this? Okay. Please tell me. You will tell me and I will solve this. So see, expectation
Sir,
of x, we know is nothing but the summation of xi and p into xi, right? Okay. So here value of x is what? 1 into probability at 1, that means 1 by n, okay, plus 2 into 1 by n, right, plus 3 into 1 by n, and so on. It will be n into 1 by n. If you see, I can take 1 by n as a common, okay, then I will get 1 plus 2 plus 3 plus so on up to n, right? You know sum of n natural numbers. You know about this quantity 1 plus 2 plus 3 plus so on plus up to n. Sum of the first n natural numbers is what?
N into n plus 1 by 2.
Yeah, it is nothing but n into n plus 1 by 2. Okay, this is the quantity. So this value will be n into n plus 1 by 2. So my n will got cancel out. So my expectation of x is n plus 1 by 2. And for this particular case, you can memorize as well. Okay, I think, yeah, you can memorize as well. Also calculation is easy. Okay, so here my expectation of x is given me as 10, right? That means n plus 1 by 2 equal to as 10, right? So now I can do n plus 1 equal to 20, right? This 2 into 10. Now it will be n equal to 20 minus 1, which will be 9. So is it clear? How suppose any question is given to you and you have to ask about something, expectation of x or expectation of x given to you and you have to find some value of a constant, then I think you will be able to solve that, right?
Yes.
Yeah. Okay. Is it clear for everyone? Okay. Yeah. So next question is based on the basically is based on the properties of the expectation. Okay. Okay. Should I tell the properties of expectation? I think you are aware. So that's why I select some questions so that we can go topic wise as well. So I hope you know, and just tell me where you are facing the problem. Okay. Okay. So before
Option A is correct.
yeah. Okay. Before this, let me cover the Bernoulli trial. Okay, Bernoulli random variable. Okay. So anybody wants to tell us what is the Bernoulli random variable?
So there are only two values that x can take as a random variable, that is 0 and 1.
Yes. Yeah.
So if yeah.
Yeah, please go ahead.
Yeah. So suppose you're getting the value of x equal to 0 with probability 3. Then you get the value of x equal to 1 with probability 1 minus 2.
Yeah. So Bernoulli random, yes, correct. Bernoulli random variable is nothing but a random variable that takes the values like on either the value 1 or 0. Okay. And see, it is taking the value 1 with probability p and c, and it will take the value 0 with probability 1 minus, right? So this is something Bernoulli random variable, and one you can interpret as a success, okay, and one you can interpret as a failure, okay. So if suppose a trial, there is only two possibilities, either success or failure, then that trial will be the Bernoulli random variable. For example, tossing a coin, okay. So after tossing a coin, it might suppose I'm interested in head, okay. So for me, suppose I'm in, for me head is success for me, so I'm interpreted head as 1 and tail as a 0. Okay, so when you toss a coin, then you will have only two options, either head, either tail. That means either success, either failure, right? So for getting for the success, you have the probability P, and for the failure, you will have the probability 1 minus P. So for getting head, you will have the probability as 1 by 2, and for tail, again, you will have the 1 by 2. Okay? Suppose, is it, I mean, till this point, is it clear? Okay, hello?
Yes, yes.
Yeah, okay now. Suppose tell me what will be the expectation of x for this Bernoulli random variable?
Sir, P.
It's P, because expectation is what? X into probability plus I mean next value of x into probability. So this quantity will be 0. You will have 1 into P, that is the nothing but the expectation. Okay, is it clear, right? Okay,
Yes.
so yeah, yes. Okay, just let me know if you are facing any problem. Okay. Next question is based on the properties of expectation. Okay, yeah, the different situation expectation is follow some property. So just after by seeing the options, tell me which option should be the correct.
A.
Okay, A and see option is about each oblique R. That means more than one option could be true.
B.
Okay, B as well.
D.
D. D.
D. Okay.
A, B, D.
Yeah, A, B, D is the correct answer. Because suppose if you remember the lecture video, if suppose you have two random variable x and y, okay, then I can write expectation of x plus y as expectation of x plus expectation of y, right? Or I can write expectation of ax plus b as a times expectation of x plus b, right? Because expectation of constant is nothing but that constant, right? So similarly here I can write expectation of ax plus b as a times of expectation of x plus b. Now come to the next option. What is the expectation of ax plus b whole square? That means expectation of, you have to apply the formula of a plus b raised to power whole square. That means a square x square plus b square plus 2 times of a b x, right? Now I see I can enter the expectation in within the bracket. So what will be? It will be a square expectation of x square. So expectation of b square will be that constant. It will be 2ab expectation of x, which is the same as the B option. So C option is not correct because in the formula of ax minus b whole square, you there is one constant. I mean one negative terms is there. So D option will be. Is that clear for everyone?
Yes.
Yeah, it is clear.
Okay. Is it clear? Yeah. No. So you are aware about the hypergeometric things?
Can you explain that? The
Which
concept?
one?
Hypergeometric.
Okay. Okay. Let me. Yes. Yeah. Let me. Yeah. One second, please. This A4 paper is visible. Okay. So hypergeometric distribution is nothing but, suppose I will start with the suppose you have okay, a box which is containing capital N box. Okay, N box. Okay, I mean in that box total capital N box is there. That means which is the population density. Okay. From this box, I am interested to choose a sample of size of small n without replacement. Okay. Okay. And this out of this n box, suppose n ball is red color. Okay. And n minus m ball is of, you can say, yellow color. Okay. So out of this, I have to take a sample of small n size, right? Without replacement. Suppose my random variable x is denoting the number of red balls. Okay. Selected, random of red balls selected. So tell me what will be the first tell me what will be the probability of x equal to I. So tell me what will be the total case? N choose n. This will be the total number of cases, right? Because we are selecting the sample of a small n size from this capital N, right? My x is what? What is the favorable? X is what? X is the number of red balls, right? So here I, that means we are drawing the I red ball, right? Initially we have M red ball. So in how many way you can select the I red ball?
MCI.
M choose I.
MCI, right? Correct, correct. Remaining will be what? I here n minus m. Okay. And see, you have choose n balls, right? And here you have choose already I, then you have to choose remaining n minus I. Okay, so your I will be. So this is something the hypergeometric distribution, and expectation of hypergeometric distribution is nothing but the n into m by capital. Okay, so is it clear? I mean, this is the something you can memorize also, expectation and all things, or you can compute by manual formula as well.
Okay.
Okay, yes. So yeah, yeah. So next question is something you can yeah, please think about it. I think 3 to 4 minutes will be more than enough for this question, right? So please solve this.
3.
One answer is 3. Okay.
That's
Anybody
3.
else?
Means 2 means
Sir? Okay, you people are trying this question, right? I'm waiting for answers from your side. So please apply the concepts. I mean, see, you have watched the lecture video, okay? So, you might be aware about all the concept and all things. So just try to apply those concepts. I mean, which should be the appropriate method for this question.
Three.
Okay, one more answer. This is 3. Okay. I will wait 2 more minutes. Okay, let's solve it. After that, we will discuss. I will be happy if I will get more responses from your side. Hello. Okay, so who told the answer as 3? Hello. Yeah, 3 is the correct answer.
Yes, sir.
Okay. Srinivasan, can you tell me what was your approach to this question so that everybody will know? Just tell me. How did you approach to this? Yeah, please feel free to say. Please.
Sir, can you scroll little up where you explain the concept above?
PO wants to verify the concept. Okay.
Yeah, I wanted to note down. Yeah, thank you.
Yeah, you can note down as well, and you can take a screenshot.
Yeah. Thank you.
Okay, Srinivasan, please tell us what was your approach to this question. Okay, I think you are not interested. Okay, see, what is the question? Question nothing but the in a software office there are 20 junior developers, right? See, this question you can do by 2 to 3 methods. Okay, by all methods you will get the correct answer. Okay, we will discuss all the methods. See, there are 20 junior developers, right? Of which 8 are men and 12 are women, right? So now you can relate. There are in software office there are 12 20, okay, junior developers, okay, initially, out of which 8 are men, okay. That means you can relate as m is red ball, right? Relate to this one, okay. M is red ball, remaining n minus m, that means 20 minus 8 will be 12 women, okay. Are you able to relate? Okay, now question is 5 junior developers are to be promoted to senior level. See, one basic difference for the hypergeometric and Bernoulli is in hypergeometric we have to do them without replacement. Suppose 5 juniors are to be promoted, 1 juniors developers are promoted to the senior level, then probability will be changed for the next junior, right? That is the meaning of the without replacement. Okay, see, here we have to choose 5 junior developer because 5 junior developers are promoted to the senior, right? Till this point, is it clear?
Can we put the 12 into 5 divided by 60?
Yes. See here I'm interested in the expected number of women, okay. So I can define x is the number of women, okay. So I can take, okay, okay, let it be, okay. Suppose initially I had 20, okay. So I'm interested in the number of women, expected number of women. So I will take, see here, what is the x? Number of red balls, okay. So m is the red balls, okay. So I'm interested in the number of women. So my m is the women, which is 12, right? So n minus m will be what? 12 minus 20 minus 12, that means 8. So these are the women, these are the number of men, okay. From this we have to promoted the 5 junior developers to the senior, right? What is the expectation of x? What is the expected first question? Yeah, expected number of women to promoted the senior next developer. So what will be the expectation of x? N into m by capital N, right? So n is what? 5 into m is what? 12 divided by 20. So 60 by 20, which is nothing but the 3. Is it clear? With this method is clear?
Sir, I have a doubt. Like,
Yes.
Expected formula is for finding, is for selecting n sample without replacement. If it is with replacement, what would be the formula?
Then this method will not be applied.
Not applied. Okay.
Yes.
So in
This
that
direct
case, how
method.
to find the expected value, sir?
This direct method you cannot apply. For that you can do next one. What is the next method? Here 5 junior developers are promoted to the next level, right? Then my x can take value what? It can take value 0, 1, 2, 3, 4, 5.
Yes.
Right? Because I'm interested in the expected number of women, right? So X is the number of women promoted to the senior level, right? Okay, so X is the number of women, and we have to promote the 5 junior developers. Okay, so X can take value 0 up to 5, because it might be there can be 0 number of women, there can be 1 woman, 2 women, 3 women, 4 women, and 5 women. I mean, values of X is clear to all of you now. Is it clear?
Yes, sir.
Yeah. Now come to the probability. See here, you are again going to some. Okay, so tell me about probability. For X equal to 0, what will be the probability?
It will be all men, like 5 men will be selected out of 8. So 8C5 into 12
8C5
into 12C
into
20C5.
12C0, 20C5.
Fine.
Because total number of cases is 20C5. X equal to 0 means, see, X is number of women, that means there is 0 number of women. That means we have to choose all the men. That means 8C5 into 12C0, right? Into, for 1, it will be, that means 1 women, right? That means 12C1 and 8C4 divided by 20C5. Is it clear?
Yes, sir.
Okay.
It's the same case of binomial distribution. Can we use
Not
it like
binomial.
because
No, it's not binomial. It's
probability of
hypergeometric.
okay.
Because what is the hypergeometric? Probability of X equal to I is nothing but the NCI, okay, n minus m, sorry, MCI, n minus m, n minus I divided by NCN, right? And I goes to 0 to 1, n, okay. So if you see m is, here my m is 12. So here in the first case I am calculating X equal to 0. That means 12C0 remaining 8C5 divided by 20C5. Okay, so similarly you can do for X equal to 2, X equal to 3, X equal to 4, and X equal to 5. Then you can apply the formula of expectation of X, summation X into Px. You will get, see, this is something what, hypergeometry, right? You are, I mean, you are doing by manually, means probability, I mean, by the formula, that means summation of X into Px. So you will get correct answer as the, again, 5 into 12 by 20. Okay, so this method will be little bit complicated. So just be remember, if it's something without replacement, okay, and these properties, all these properties are satisfied, then it will be hypergeometric. Okay, is it clear? Then I will proceed for the next method for the same. Okay, so let's see. We are promoting 5 for 5, right? Suppose xi, I'm defining xi a random variable which is equal to 1. Then see here we are interested in the number of women, right? So X will take, so that means I'm interested as a this will be something success. So my xi will take value 1 if women is selected, right? Now xi will take the value 0 if men is selected. Till this point is okay. Suppose you select a person, you have only 2 options, either it will be men or women, right? Is it clear? Is it clear for everyone?
Yes.
Okay. So there are initially 20%, out of which 12 are women and 8 are men. So tell me, what will be the probability for selecting a women? Suppose you select a women, then what will be the probability?
1 by 2.
1 by 2. Why?
Because there are only 2 options. Either a man should be selected or a woman should be
No.
selected.
See, you. I'm not saying you have to select men and women randomly.
1 by 20, right?
No, Amit.
Prashant, what is the question? Repeat the question.
Yeah, I'm saying, what will the probability for selecting a women? And this is the case you are given to.
1 by
1
8.
by 12. 1 by 12.
1 by 2.
1 by 20.
1 by 20.
3 by 5.
Because see, you have total number of cases 20. You have 12 women. So for selecting a woman, probability will be 12 by 20. That's it. Is it clear?
Correct, yeah.
So for selecting a man, what will the probability?
8 by
8 by
20.
20.
Yes.
Now, so this is something what? This is something, if you see, this is something Bernoulli random variable, right?
Yes.
So what will be the expectation of xi?
12 by 20.
1 into 12 by 20 plus 0
Plus
into
0
8
into
by
8 by
20, it will be 12 by 20,
Yes.
right? But this is for the ith person, right? Ith junior developer, right? Here we have to do for the 5 juniors. That means expectation of x1 plus expectation of, x2 plus x3 plus x4 plus x5. It will be summation of I is equal to 1 to 5 expectation of xi, which will be summation of I is equal to 1 to 5 12 by 20, which will be 5 into 12 by 20. That means 60 by 20, which is again 3. Here property of expectation is flat. Is it clear? This method is clear.
Yes. Yes, sir.
Okay. Yeah, is it clear for everyone?
Yes.
Yeah. Okay. So hope you will be able to solve the question. So yeah, next question is based on the variance. You know what is the variance? What variance tells us? Actually, variance, see, by the expectation, we know the long run average. Okay. But we did not aware about the variation or spread of the data. Okay. So my variance is tells is nothing but the variance of x is tells us the expectation of x minus mu square. That means variation of the values of x from its mean. Okay. And there are see, if you expand this formula, then you will get this formula. Again, you can, you can have this formula. Okay. So these are some variance of x formula. One formula can be this one. Just this is same as this one. This is same as this one. Okay. If you will expand this, you will get this. Okay. This is something the variance. Okay. So next question is based on the. Okay. So before starting the next question, so tell me what will be the variance of a constant? What will be the variance of a constant?
It'll be 0, right?
It's a 0. Yes. Because
0.
see, variance of x is what? Expectation of x minus mu whole square. So variance of a, that means expectation of, here a is a. Okay. And again a, because expectation of a constant will be same as the that constant, then it will be 0. So tell me variance of ax.
A into variance of expectation.
Anybody else?
It's a square
into a
to
square
variance.
To a square variance of x. Okay. So tell me what about variance of ax plus b?
A square
should be
variance
a
of
into
x.
variance of x.
Yes, there is does not affect of adding or subtracting a constant to the variance. Okay, because if you apply the if you apply the value here, you will get the correct answer, right? Because variance, should I derive, or you are aware about that? If you are aware, then we can proceed, because we have to cover other lectures also. Okay, so tell me if we have x and y random variable. Okay, then what will the variance of x plus y?
Variance of x plus variance of y.
When
If x and
only
y
when
independent.
x and y are independent. Yes, correct, Sami. Because this is the only case for the variance. It does not matter about the in case of the expectation, but it matters in the case of the variance. Okay. So next question is something which is based on the something variance and property of variance. So please read the questions carefully and apply that concepts of variance. Okay.
$25 cube.
25.
25 cube.
Okay. Anybody else?
0.
Okay. Someone said 0.
Variance will be the same because any constant that is being added to the previous, that is old variance, will not have a change. So it should be 25.
Okay. 25. Anybody else?
Go with the first option, 25 cube, 15,625.
15,620. Okay.
15,625.
Okay. 15,625. Major votes are going with the 15,625. Okay, so yeah, 15,625 is the correct answer. So those people tell me how did you approach to this question?
So V of X was already given and it was 25.
Yeah.
Then we added to each ticket a profit of 25 was added. That means X plus 25 is something that we have to find out. So it would
Okay.
be A square Vx. That means 25 square into
Why
Vx.
25 is square? You are saying variance of x plus 25, then it will be only variance of x.
In this case, for profit is 25 per ticket. So 25 into x.
25
So
times.
variance
Yes,
of
25
25x.
into
So
x.
that is 25 into.
So a square, that means 25 square. See, okay. Yeah, this is the correct answer. See, what is the question? See, please be focused. Variance of number of tickets sold in a day in opera theater is 25. Okay, so let x is the number of tickets. Okay, sold in a day in an opera theater. Okay, now variance of this thing is given to me, which is nothing but the 25. Okay, now it is given that if for each ticket sold the profit obtained is 25 rupees, then what is the variance of the profit obtained in a day in rupees square? Okay, so what is the given to us? For each ticket sold the profit is obtained is 25. So for each ticket profit is 25 rupees. Okay, so see, we have x tickets which is sold. So tell me, for one ticket profit is 25. So for two ticket, how much it will be?
50.
50. For three ticket,
75.
For four ticket, 100. So similarly for x tickets, 25 into x, because 50 is what? 2 into 25, 3 into 25, 4 into 25. So x, for x number of tickets, profit will be 25 into x. So here we have to just find the variance of 25 into x, which will be 25 square, into variance of x. It will be 25 square into variance of x is 25. That means 15,625. Is it clear for everyone?
Yes, yes.
Okay, now it's clear. The people who have answered 0 and 25, I mean, you got there. I got.
Sir, I have a doubt, but the first line says that the variance for all to, for any, X number of tickets sold is 25. So it is altogether, right? It doesn't refer to that. It is a.
See, no. What is your x? X is number of tickets. Okay, you do not know how many tickets you have sold, right?
Can you show me the question once, sir? One more time.
Yeah. See, please see. Question is variance of number of tickets. Okay. Suppose let's assume 2 tickets has been sold. Okay. So variance of 2 tickets sold in a day in an opera theater is 25. If for each ticket sold the profit is 25 rupees, then what will be the variance?
The
That
question,
is variance of
nowhere it is told that the number of tickets is 25, right? See, first line states that the variance is 25.
where I'm saying
Second
number
line
of tickets is
states the
25.
profit. No, the variance is 25 is different from the number of tickets 25, right? Or is it the same?
No, I'm not saying number of tickets is 25. I'm saying X is the number of tickets sold in a day in an opera theater. Variance of number of tickets sold in an opera theater, that means variance of X is given as 25. This step is clear or not?
Yes, no, I'm not. See, they have told the variance is 25, but I'm not getting how come we got how do we determine that the number of tickets is 25? From where you are getting the
Why?
number of
Where
tickets?
where I'm doing the number of tickets 25? These things.
So first line, see, just let me know if I'm wrong. See, first line states the variance is 25, right? It doesn't say
Yes.
about how many number of tickets sold in a day.
But
First, it doesn't
variance
say.
is variance is what? Variance is what? What variance is given to us? Variance of, okay, so can I define X is a number of tickets? So just be focused. Number of tickets sold in a day in an opera theater. Can I define this is as a X? These things, I'm saying this is my X. This black covered region. This is my X. Is it clear?
Okay.
Okay. So variance of these things is given to me. Variance of this is 25. That means variance of X is given to me as 25.
Yes, sir.
Now, question is, if for each ticket sold, okay, the profit obtained is 25 rupees. X is showing representing the number of tickets sold. If for suppose one ticket's profit is 25, so for two ticket, how much it will be? 50.
Yes, sir.
So for three tickets, it will be 75. Similarly, for X ticket, I can say profit is 25 times X. See, for two tickets,
If we write
that
it
means
as
what?
a formula, no, what I'm telling, if we write it as a formula, for each ticket it comes as the cost of the ticket plus 25, right?
Sorry?
If we write it as a formula, as a generalized formula, it comes as cost of each ticket plus 25 rupees, which is the profit. So, I mean, it should be plus 25 for each ticket, right?
No, why plus? Okay, see,
Because the profit
S is what?
obtained should be added
S
to
is
the
what?
cost of the
Not,
ticket.
not, no, cost is where cost is given to us.
See, the
Profit is given to us already.
yes,
Right?
sir. So, which must be added to the ticket amount for which we are selling it, right?
Where is amount is given to us, Samiti? Please tell me. Amount is given to us.
Amount is
Is
not
it,
given, but I'm telling in general, if X is the
in
cost
general,
of
is
a
that there?
ticket,
Okay. Profit you have to add something, right? But
yes,
here in the question, variance of the number of tickets is sold is given to us, right? Suppose let's assume X is for hypothetically assume X is the three tickets is sold, okay, and variance suppose for example, okay, let it be. This thing is clear. Suppose X is what number of tickets. This step is clear to you. First step,
yes, sir, that I'm clear.
yeah.
X is
Each
the
thing
number.
we focus on for each ticket sold, right? Profit obtained is 25 rupees. Suppose for one ticket, profit, see, for each ticket, profit is 25 rupees. So for one ticket, profit is 25 rupees. So for two ticket, it will be, see, 25 plus 25. Okay.
Okay, sir.
Right. Which is same as 2 into 25. So for three ticket, profit will be 25 plus 25 plus 25. That means 3 into 25. So similarly, for X number of tickets, profit will be 25 plus 25 plus 25 and so on up to X time. So it will be 25 times of X.
Okay, sir.
Okay.
Okay, sir.
So Now this quantity you have to find. Now it's clear?
Yes, sir. Yes, sir. I got it now.
Okay. Yeah. Okay.
Thank you, sir. Thank you.
Yeah. Thank you. So you guys have cleared about expectation and variance, all things, right? Yeah. So let's come to the next question. Next question is based on the standard deviation. It's based on the standard deviation. And you know what is the standard deviation? Standard deviation of a random variable x is nothing but the square root of a variance of x. So, and here you have to apply the property of variance as well. So please apply the property of variance and formula of concept of standard deviation, then you will get the correct answer for the which is the required.
Square root of variance, you said, isn't it?
Sorry?
This is the square root of variance.
Yes, yes, it's the square root of variance.
The answer is 5.
Okay, one answer is coming. Answer is 5 from Rajni, right? Or Ranjini?
Yes, yes.
Yeah, yeah. So one answer I got, which is 5. Okay, anybody else?
$17.
Comes as 17, square root of 17.
Yeah, square root of 17. Sorry, yeah.
Square root
So
of
find
17.
the standard deviation.
Square root of 17. Okay, major votes is going for the square root of 17. And I think Rajni has says 5, right?
Yes, yes.
Anybody else? Variance of x is given as 2 and z as 7. Okay, variance of x is given as 2 and variance of z is given as 7. So we need to find the variance of standard deviation of x plus y. Okay, so let's proceed. So see, for finding the standard deviation, we see variance is given to us, so it will be convenient to us. First find the standard variance of this quantity and after the put the value, I mean take the square root of. Okay,
5.
so people, you have did like the variance of uh, x plus variance of 2y plus variance of z. Okay, so variance of x is 2 plus variance of y is will be 4 times of variance of x plus variance of z is 7. Okay, so 2 plus 4 into variance of x is the 2 plus 7. So 2 plus 8 plus 7, it's a 70. So standard deviation of x plus y plus z is nothing but the square root of 17. So square root of 17, I got the answer from major, which is not a correct answer.
Because y is not independent.
Yes,
Not split like that.
yes, yes, we cannot do like this. We have only information about x and z are independent, not x, y, and z are independent, right? If you know, when I can write variance of x plus y as variance of x plus variance of y, only when my x and y are independent. So similarly, x plus y plus z is, it will be same variance of x plus variance of y plus variance of z only when my x, y, and z all are independent, right? So correct approach is we have to find y plus y plus z. We have y as 2x, so we can do variance of x plus, we can replace y as 2x plus z. We will get variance of 3x plus z. We will have 3 square variance of x plus variance of z. We can write it because x and z are independent. This information is given to us. This will be 9 into variance of x 2, variance of z is 7. So it will be 18 plus 7, which is 25. So variance is 25. So standard deviation of x plus y plus z is nothing but the square root of 25, which is nothing but the. Is it clear now? Who has given the answer square root 17? I mean, is it clear for everyone?
Prashant, one question. It's given
yes.
that variance of y equals to 2x, not that y equals to 2x. B of y is equal to 2x, not y equals to 2x, right?
No. Y is equal to 2x is given.
Oh, sorry. Yeah.
Okay.
Yeah, sorry.
Is it clear now?
Yes.
Okay. Yeah. So suppose in any question x is given to 1, 2, 3, and so on up to n, and probability is given, let's assume uniform 1 by n, 1 by n, 1 by n, and so on 1 by n, then you will be able to solve the, suppose I take question is, I said calculate the variance of x, then you can calculate the variance of x, right? You can do expectation of x square minus expectation of x whole square. Okay, you can compute this quantity and you can compute. So tell me how you will compute the expectation of x square. That means, well, square values, you have to do the square of the values of x into probability, then 2 square into 1 by n, and so on, n square by into 1 by n. So similarly you can. So I hope week 10 is covered from our side. So now we will proceed the, see, I had only up to this week 8 question. Now we will cover the concepts of now week 11 also onwards. Okay, till this point is it clear for everyone? Till week 10, all the concepts, variance, expectation, standard deviation, and all things.
Yes.
Okay. So in week 11, you know, you are aware about the Bernoulli trials. Okay, a trials where we have only two possibilities, either success, either failure. Okay, and you know, Bernoulli, let's accept the Bernoulli trials, then it will take value 0 and 1 with probabilities 1 minus p and p. Then what is the expectation of x? You know, summation of x into px, which is 0 into 1 minus p plus 1 into p, which is nothing but the p, right? So what will be the variance of x? Formula, you know, expectation of x square minus expectation of x raised to the whole square, right? You have expectation of x, you have to compute the expectation of x square. So expectation of x square I can compute. The x square means you have to take the square of the x value. So 0 square into 1 minus p plus 1 square into p, it will be 0, then again it will be p. Okay, now this is the expectation of x square. So variance of x will be, put the values in the formula, it will be p minus expectation of x is already p, it will be p square. So p minus p square, nothing but p into 1 minus p. So this is the variance of the Bernoulli random variable. Okay, if you remember, there is something concept, a concept, most uncertain Bernoulli trial. Okay,
In which
Can you
situation is
just
this applied?
explain the term?
Sorry? Where is this applied? In what sort of situation is this Bernoulli?
This Bernoulli
applied?
trials, yeah,
Yeah.
the situation where you have only two possibilities, success or failure. Right? Suppose I have experiment tossing a coin. Okay.
Yeah, tossing a coin. Yeah.
Okay. Then suppose my success, I'm interested in, as a head. Okay. So my x is taking value 0, 1, right?
Yeah.
Okay. Suppose x is what? See, it depends on what is your success. It's not about success is something. Suppose yeah, x is, I'm interested in the head. Okay. Number of head. Okay. Getting head. So probability 0 means 10. That means probability will be half.
Yeah.
for it. So what is the expectation of x? You know, by the Bernoulli formula, it's p. That means you can directly write it down 1 by 2, right? Variance of x, you can directly write 1 by 2 into 1 minus 1 by 2. That means 1 by 4. So there are some examples like, see, success is not about a good thing. Is suppose success can be like number repeat. Yeah, suppose in a manufacturing company, I took a sample of 5. Okay, there I am interested in the finding the number of defective items. Okay, so suppose I have defined my x is the number of defective items, so my success probability will be probability for being a defective item. Okay, suppose you took a product, then it will be either it will be defective or it will be non-defective. So are you getting my point?
Yeah. Wherever it is a Boolean.
Yeah, where it is. See, now come to the binomial random variable or binomial distribution. See, in Bernoulli, when you have to do an independent trials, okay, an independent trials, and S is the number of success, then combination of each independent trials will form a binomial random variable. See, binomial random variable is nothing but the number of success in an independent Bernoulli trials. That means, see, Bernoulli trials, for each trials, you have two outcomes, either success, either failure. Thus, these trials, you have, suppose you have performed independently n times, then it will take a form of binomial random variable. And PMF, or you can say distribution of binomial random variable, is nothing but n choose I, success probability p raised to power I, failure probability 1 minus p raised to power n minus I, and my I is taking the value, sorry, x is taking the value 0, 1, 2 up to, okay. So you are aware about this binomial, means the Bernoulli is what? At each trial, you have two things, one, a success or failure, okay? A success or failure. Suppose you are performing your trials in there are an independent trials, it will take a form of binomial random variable. Is it clear for everyone? Hello?
Yes.
Okay. Yeah. Let's understood by an example. Suppose you can say like what I can say, example you can take. Suppose let's take a manufacturing company. There is a manufacturing company, and inspection team goes in that manufacturing company for inspection of the items. Okay. Now, the owner of the company says the probability of being defective, probability of being defective of a product is, let's take 0.05. Okay. And the team choose a sample of 5. Okay. Then tell me, what will be the probability that there is no defective items out of these 5 defective? What will the probability? Just a formula, not answer.
So 0.5 is the 0.05 is the possibility of a
probability of being defective of that item.
Okay, so non-defective is 0.95.
Yes.
Okay, non-defective is 0.95. So you need all are non-defective, right?
Yes.
So you need, so it is 5C5.
All are see, no defective, when there is not defect. There is you can say all non-defective.
All non-defective. So if you're considering all as non-defective, it's 5C5, 0.95 raised to 5, 0.05 raised to 0.
So Prashant, it's 5C0.
Yes.
0.05 raised to the power 0. 1
Yes.
minus means 0.95 raised to the power 5.
5. Yeah, this is the correct. Because why? What is my x? What can be my x? My x will be, see what I say, what is the given in the question? Question is given that probability of being defective of an item is 0.05. Okay. So x is, suppose let's take number of defective in the sample. Okay. And we took a sample of 5. Okay, that means my x can take value 0, 1, 2, 3, 4, and 5 according to binomial distribution. Right? Now, question is, there is, you can say none are defective. Okay. So none are defective means what? No defective means your x is what? Number of defective. None are defective means my x will take the value as 0. Right? See, here is binomial, because if you took an item, then it either it will be defective or it will be non-defective. So 5C 0 NC I P raised to power I. So success probability here is 0.05 raised to power 0 and 1 minus 0.0 raised to power 5. It will be n minus I. That means 5 minus 0. It will be 5. So is it clear how you can compute?
Yes.
Okay. Okay. Suppose probability is 2 or more defective. Hello. So tell me, what will be the next step? Probability of 2 or more defective.
We have to compute for x is equal to 2, 3, 4, and 5.
That means x
And
equal to
add them.
greater or equal to, right? 2 or more defective. Suppose tell me about probability of at least one defective. What will be the equation in terms of mathematical notation? It should be clear.
1 minus
1
probability no
minus
defect.
0 to
Yes, you can do. See, what is the probability of at least one defective? Means probability of x greater or equal to 1. See, at least 1 is what? There should be, I mean, it can be great 1 as well as greater than 1, right? I mean, there should be at least 1. It can goes beyond the 1 as well. So I can write it as 1 minus probability of x is less than 1. Okay. So x is less than what? Your x is taking value 0 to 5. So I can write it 1 minus probability x equal to 0, because less than 1 is only one value, which is 0. Right?
Yes, yes.
So similarly, you can compute the probability. Suppose I'm saying probability of at most 2 defective items.
X
0
equal to
plus
0,
1
1
plus
and 2.
2.
Yes. At most 2 means
Less than or equal to 2.
yes. So these things should be clear to you. I mean, you can say this is a hint, or this is a suggestion, or whatever you can take it. This type of questions might come in the exam. Okay. At most, at least. Okay. So you have to be careful, because sometimes students are making mistake. At least is this one. At most is, I mean, reverse thing. Okay. So be careful about this. Okay. Is it clear?
Yes.
Okay. Now come to the expectation of binomial random variable and variance of a binomial random variable. Okay. See, what is x? See, what I explained, after an independent trials, okay, an independent Bernoulli trials will form a binomial. That means I can say x as a x1 plus x2 plus so on xn, where my xi is a Bernoulli random variable. Can I say or not? Can I say?
Yes.
Binam Gupta has raised hand. Yes, please.
Can you repeat the question, please?
Yeah, question is saying, see, in binomial is what? is nothing but the collection of n independent Bernoulli trials. In each trial, success is there or failure is there, right? So I can write, suppose I'm saying xi is a Bernoulli random variable. So I can write x, which I'm interested, I can write x as a binomial random variable, which is sum of all the Bernoulli random variable or not? I can write it.
Yeah.
Okay. You know, expectation of x is say is equal to expectation of x1 plus expectation of x2 plus so on expectation of xn. Okay. So I can write expectation of x1 plus expectation of x2 plus so on expectation of xn, right? If xi is the Bernoulli random variable, then what will be the expectation of xi in case of Bernoulli?
P.
N into P.
It's not in, it's only P, because for Bernoulli it's 0 and 1. 0 for 0 it's 1 minus P, for P it's 1 for its P. So expectation of xi is P. So expectation of x1 will take P, expectation of x2 will take P, and so on up to P. That means expectation of x will be n into P. So this is nothing but the mean of the binomial random variable, expectation of the binomial random variable. So suppose in any question n is given to you, you know P, then you can directly calculate the value of expectation. Is it clear?
Okay. This is similar to the software development problem, right? 12 men.
Yes.
And 8 women. Same. Is just that n is equal to 5.
N was 5 and P was
5 and P is 12 by 20.
12 by 20. Because if you remember there, I had explained where it was. Yes, here I explained xi as the Bernoulli, which is taking value 1 for women, this is taking value for the, okay, and here I have applied the property of expectation. So it depends how you are approaching to a particular. Okay, so similarly, see, I said an independent Bernoulli random variables. So similarly, variance of x will be variance of x1 plus so on variance of xn. So see, these variables are independent. So I can write variance of x1 plus variance of xn. Okay, you know, variance of Bernoulli, it's nothing but p into 1 minus p plus p into 1 minus p, and so on up to n times p into 1 minus p. So I can write np into 1 minus p. Is it clear?
Yes.
Is it clear for everyone? Okay. Suppose I'm asking a question. Suppose, let's tell me. Suppose a fair coin is tossed. Let's take 10 times. Okay. Okay. So what is the standard deviation of number of times that head appears? Standard deviation of number of times a head appears. I'm saying a fair coin is tossed. So you will be aware about the fair coin. A fair coin is an unbiased coin means probability of getting a head or getting a tail is same. That is half. Is it clear? That is the meaning of fair coin or unbiased coin. So you roll a fair coin 10 times, then what will be the standard deviation of number of times of head appears? So please tell me the answer. What will be the answer?
Square root of 5
Under
by
root, under root 10 by 2.
10 by
2. No, 2 is full. Under root 10 by 2.
No.
It
Square
will be
root of
10 by
5 by
4
2.
actually.
Square root of 5 by
Root
2.
of 10 by 4.
Here, you know, x is followed by binomial as n comma p.
Yes.
Then expectation of x will be np and variance of x is the npq or np into 1 minus p, right? So tell me, my here x is follow 10 comma 1 by 2, right?
Yes.
Is it clear? So variance of x is what? N is 10, P is 1 by 2, and 1 minus P will be again 1 minus 1 by 2. It will be 10 by 4. So standard deviation of x will be square root of 10 by 4, which is square root of 10 by 2. Okay. So it's option correct. Is it clear for everyone? Okay. So is it clear?
Yes, yes.
Suppose in any question, expectation is given to you for a binomial random variable as 6. Okay. Then and n is 10. Okay. So tell me how will you compute the probability as x equal to 8? Just hypothetical example.
6 by 10.
Probability of
See,
x equal to 8?
Yes, you have to find the probability of x equal to s. You are given this quantity and this quantity, then how can you compute? How will you proceed?
6 by 10, sir.
Sorry?
6 by 10. It is 6 by, because.
Okay, you are saying 6 by 10, okay?
Yeah.
Okay, anybody else?
This is for expectation is for a binomial distribution.
Binomial random. Yeah. It's
Okay,
for
okay.
a binomial random distribution.
Okay. Okay, so the
This
thing
is
is,
10.
so you are getting NP equal to 6, correct?
NP equal to 6. Okay.
NP is equal to 6.
And P is equal to
10.
6 by 10. P is equal to 6
Okay.
by 10. And you're having, okay, so
Yeah,
P is
see,
equal to 6.
1 second, Ranjani. I
Sure.
think Srinivasan has told 0.6 initially, right? Srinivasan, the quantity you have told, this is nothing but the success probability. But my question was probability at x equal to 8. Okay. Here
If I
your
choose
x
8,
can take, yes, your x can take
3 by
0
5 raised
of
to 8
1 up to 10.
into 2 by 5 raised to 2.
Not 5 by 5.
10C8.
Yeah, your n is 10, so it will be 10C8.
Yeah, 10C8. Yeah.
0.6 raised to 8 raised to 8.
Yes.
0.4 raised to 2.
Is it clear for everyone? If any question will come related to the binomial, then I hope you will be solved to the questions. Well, this is nothing but in any question, expectation will be given to you, and will be given to you. You will ask success probability, and in any question, suppose this thing is given to you, will ask some probability at a particular value of x. Or let's assume you have given the PMF, you have asked the success. Sorry. Suppose tell me, x is 0, 1, 2, 3 is given to you, and PMF is given to me. Like, let's assume hypothetically, this is 1 by 2, and this is let's say 1 by 4, and it will be 2 by 4, 3 by 4. Again, it's 1 by 2. Not 1 by 2, it will be 1 by 4, 1 by 4. So it will be 2 by 4. That means let's say all are 1 by 4. Okay. So this things is given to me, and I'm saying x is a binomial random variable. Okay. So tell me, yes, I think there are some background noise.
This call will not be returned to you. What is this?
Yes, please mute yourself. Hello. Yeah. See, suppose I'm saying x is a binomial random variable and PMF of a binomial random variable is given to this. So tell me, what is the success probability? How can you, how will you proceed to find the success probability?
So we need to find what is the event here. We have to define the event. If the event
I'm
of
saying
getting
see, Ranjani, I'm saying x is a binomial random variable and PMF for a binomial random variable is given to me, which is this thing. Okay. So tell me what will be the success probability? That's it.
Success probability. So that will be based on event, right? So success of getting a 0 will be 1 by 4. Not getting a 0 will be 3 by 4. Getting a
no, not success.
We'll use expectation of is equal to n into p,
Yes,
and
yes,
that way we
you
can
can use expectation of x. See, I'm saying success probability is I have to find the value of p, right? So you can use expectation of x, right? By this PMF, you can compute the expectation of x by this formula, right, Ranjani?
Yes, correct. Huh.
Okay. Suppose whatever you will get, hypothetically, I'm taking as 6. I mean, this might not be okay. Let's compute. It's 1 into 1 by 4, 2 into 1 by 4. 1 by 4 plus 2 by 4 plus 3 by 4, 3 to 5, 6 by 4,
1.5.
1.5. Okay.
Huh.
So 1.5. Okay. My n is as 3. So my NP is given to me, n is 3, then I can compute P or not.
Okay. Got it.
Okay. First
Okay.
approach. Second approach can be, see, this is the PMF of a binomial distribution. Then I can write probability of x equal to 0 is nothing but the 3C0 and what is this? Let's take p raised power 0. 1 minus p raised power 3 is given to me as 1 by 4. So 3C0 will be 1, p raised power 0 will be 1, 1 minus p raised power 3 will be 1 by 4. So you can compute from here as well. Is it clear for everyone?
Yes, got it.
Got the concept?
Got it.
Okay. So I think
In
week
case,
11.
sir, n is equal to 1, 2, 3, 4, no, right? N is equal to 4.
N is 3. N is 3.
Okay, 0, 1, 2, okay, n is 3. Yeah. Okay.
Not counting. See the last value. If x is
Yes.
n number of tries, then s can take value 0 to n. Okay. Is it clear for everyone? Similarly, these things you can find from the last value as well. That means probability of x equal to 3, 3C3, p raised power 3, 1 minus p raised power 0 is given to us 1 by 4. So this quantity will be 1, this will be 1. So p raised power 3 will be 1 by 4. See why I took the first and last value. You can compute by this value, but your equation will be a little bit complicated because it will be 3C1. Let's say it 1. It will be 1, 2. So you have to do a little bit more calculation. That's why. So you can proceed either by calculating expectation of x and n is given to us and p. Okay, is it clear for everyone?
Yes.
So for anybody have any doubt? Otherwise we can move for week 12.
Yes.
Okay. So yeah, 1 minute. See, till week 11, we have covered, distributions, PMF, expectation of random variable, variance of a random variables and all things. But we see that some distribution, PMF for a discrete random variable. Okay. In week 12, it's about continuous random variable. Do you know what is the continuous random variables? Which can take any possible values, which can take any values along with a given interval, right? Okay. So for discrete, we had PMF, okay, probability mass function. For continuous random variable, okay, we have to define the PDF. That means full form is this probability density function. Okay, this is the something. Okay, you had the properties of PMF, how you can find the properties. All the probabilities should be 0 to 1 and sum of all the probabilities should be equal to 1. Okay, but in the case of continuous random variable, we have, let's assume some area. Okay, so suppose this is your fx and this is your x. So suppose a value is a is here and b is here. Okay, so this is something, let's take, this is the area. Okay, so PDF is what? There is two properties of PDF. The all region, this shaded region. Okay, this shaded region should lie between 0 and 1. That means I can write 0 lies between probability of x lies between a comma b should be equal, less or equal to 1. Okay. Yeah, please mute yourself.
Sorry.
If who has
Sorry,
not
sorry.
doubts, yeah,
Sorry.
it's okay, but yeah, please, because background disturbance. Okay, so you know this area under the curve, this thing should be, I mean, this value should be lies between 0 and 1, as same as in case of PMF, right? In the PMF, we have to add the probabilities, and that all the by adding the all the probabilities, this should be equal to 1. In the case of continuous, we cannot add. We have to integrate throughout the region, the given PDF, and this should be equal to 1. Is it clear? That means this throughout the region, your PDF should be 1. I mean, not it will be A to B, it will be whole R fx dx. So that is something concept behind the PDF and all things. Is it clear for everyone?
Probability density function.
Yes. Suppose I'm saying probability of x a is less or equal to these things. Okay. Then suppose this is your A, this is your B. Okay. This is your fx. That means what? That means I have to integrate A to B fx dx. See, in discrete, there is a lot of these things. There, these things matter in equal to and all things. But in continuous, is these things is not matter. Okay. These all things are same because we have to just integrate under that area, right? So all these things are equal. That means in discrete, probability is x less or equal to 2 means what? It was probability of x plus probability of x equal to 2, right? Suppose your x is starting from 1, 2, 3, 4, and 5. Okay, I'm comparing with the discrete. Okay, but I'm suppose saying probability of x is less than 1. That means less than 2. That means you have to add, you have to take only probability of x equal to 1 in case of discrete, right? Is it okay or not? This thing is you are getting or not?
Yes, because 1 and 2 are separate numbers
Yes,
for discrete.
numbers.
Yeah.
But in case of continuous, suppose I'm saying x is less or equal to b. That means you have to suppose lower limit is 0. Then you have to take 0 to b fx dx. And suppose I'm saying 0 to x to less than b. Then again you have to take the 0 to b. That means in continuous, these things doesn't inequality is not, because you have to just take the integration. I mean, you have to take the shaded region of the between the. Is that okay for everyone?
So in this case, if less than or equal to and less than, are you saying
Yes.
that they mean the same?
Yes.
So if it is, what happens in
Because
the case
Madhu,
where x is equal to p in that one, the second equation, x is equal to p. If when we are saying the limit 0 to b, it will include b also, right?
yeah, in the case of less than b also it will include b. What is the issue? Not issue. What is the case? See, in the integration thing, suppose my this is your say, this is your a and this is your b. Okay, I'm saying you have to find the probability a to b. Okay, that means you have to find this region.
The shaded pole. Yeah.
Again, saying suppose I'm saying a before b up to b. That means again you have to find this region.
Yeah.
Okay, that's why all the things are same in the case of continuous, because it's basic, it's a continuous, not a you can take a distinct values, right? Not a you can separate kind of things. You have to find the region of the between the given the inter. Are you able? I mean, are you getting my point?
Yeah, it's very clear to
Yes.
understand what lies in between, but the only difference or the only confusion is the inclusivity of.
No, not inclusivity. Okay, so tell me, suppose a is less than. Okay, so this is your a, this is your b. Then you then how you can, this is the continuous thing. Then how you can differentiate it's from a plus one kind of thing.
I was what I thought was it will be, you find the probability of this continuum. Okay, find the integration of this and subtract what is only A. Is that not the case? If it is
Okay,
just
then,
A,
okay, just
P of
okay, Madhu. So
integration.
tell me
Sorry,
what
I'll just my
please.
my
Please.
understanding. So my understanding was it is integration, limit A to B, f of x minus P of A. Is that not correct?
F of x
That was the formula
minus,
that you gave.
minus P of A.
Yeah, just P of A.
This will be in case of discrete. See, just tell me, if you are saying this one, that means f of x. No, that means if you are
No. The formula that you actually put earlier, the integration formula, that minus only the P of A.
So okay. So then, in that case, what you will take a lower limit?
Yeah.
You are subtracting P as x equal to, then what you will take a lower limit?
Yeah. A and B. You take the you do
okay.
the whole
You
thing.
are taking again A and B, and you are saying subtract my B.
Because it says A less than X. So I'm sorry if that is not the case. It's okay. I will understand that. Okay, it does not. Okay.
Okay.
In this
So
case,
for
I understand that it is all the same.
Madhu, for more clarification, I will suggest to you, you can rewatch the lecture 12.1.
Okay.
Okay.
Thank you.
For more clarification. Yeah. For more clarification. Yeah. So far, you got the concept what I'm trying to say, because in this, how you can be able to differentiate between less than B and up to B, right? It's just about your region, given region, right? A and B, right?
Yeah, got it.
Because it's a continuous, it's like 1.1, 2, 3, 4, 5, 6, 7, 9, 8 kind of things. Okay. It's not a discrete. If it's discrete, then you are very, easily able to separate the values, as we did in the case of Bernoulli, binomial, and all things in the previous cases. Okay.
Yeah, got it. Thanks.
Okay, got it. So tell me. Yeah, once more. Yeah. So tell me, probability of A less than x less than B equal to integration of A to B fx dx, right? So tell me probability at a single point in case of continuous.
Zero.
Because integration at a single point will be, what was that? Probability density function of I think you can say like not
It
like
will be A to A means again finally it's 0.
yes, yeah, that is the correct, because x equal to A means I can say these things, right? That means A to A fx dx, that means probability at a singleton point in case of continuous will be 0. Okay. Now come to the CDF. In case of this suppose this is okay, this is A. So in case of discrete random variable, what we did, we add all the probabilities before this point. Am I right?
Yes.
So in the case of continuous, you have to integrate the things before this point, right? Let's take lower limit as a minus infinity. Then you have to do the integration up to A. Okay. Is this clear?
Yes.
Okay. So similarly, tell me, in the case of discrete, expectation of x was x px, right? So in the case of continuous, it will be integration of x into fx dx. This is for continuous, this is for the discrete.
Correct. Yeah.
Okay.
Yeah.
So for continuous, variance will be what? Expectation of x minus expectation of x whole square is there. Okay, so I can do integration of x minus expectation of x square into fx dx, right? I mean, such complicated integrals will not be there in the exam, but I'm trying to explain all the concept. That is the fundamental thing. But I mean, such more complicated exam. I mean, question related to integration where you have to apply the integral will not be there. Just there will be questions related to CDF and all things. I mean, you can apply the area formula and all things, right? Okay, suppose a question is given to like this. Okay, this is x, this is fx, like this things. Okay, suppose this is the 0, so this is the 0.25, suppose 0.5. Let's take this is the 1, and this is the 1. This is the 2. So can you tell me whether this given by the given graph, whether it is PMF, PDF or not? And if first of all, tell me how did you approach this? Suppose I'm asking about region is given to you, then how did you approach for checking the PDF?
Area under curve.
Area under the curve
Integration
should be
0
equal
to
to
1.
1. Sorry? Yeah.
It's integration 0 to 1 fx dx plus integration from 1 to 2 fx dx, and then 2 to 3 fx dx.
Okay, that is the one approach. Another approach you can do, I can draw a line here. Okay, a line here also. Suppose this is my region 1, this is my region 2, this is my region 3. So what will be the probability for region 1? Area of this region 1, that means 0.5 into 1. This is the rectangle. Area of rectangle is what? Length into breadth. So this is 0 to 1. This is your breadth, and this is okay 0.5 into 1, that is the 0.5, right? Are you getting my point? So for probability of region 2, what will be the area for these two?
1 into 1.
1 into 1.
1 into 1, which is 1. Probability of for 3, 1 into
0.25 into 1.
0.25.
If you add all these probabilities, it is going greater than 1, right?
Yes, yes.
So this is not a area. Okay. So suppose any picture is given to you kind of, then you can find the apply the area formula, right? Area of a rectangle, area of a triangle, and kind of things. Okay, is it clear for everyone? Hello.
Yes, yes, yes.
Till this point, yeah, it's clear. Now come to a very important, you can say distribution, uniform distributions. Okay. In the discrete, we have also studied a uniform distribution, but that was in case of discrete. What was the case? Your x is a random variable which are taking the values 1, 2 up to n, and probability at each value of x is same. Okay, then it's a discrete uniform distribution. That was another. Here in the case of continuous uniform distribution, suppose a random variable x I have and it's follow uniform a comma b. Case is a should be less than b. So what is the meaning of uniformity here? Suppose this is your fx and this is your x. Okay, this is your fx, this is your x. So suppose a is here and my b is here. Okay, so what is the meaning of a and b? I mean uniform distribution, x followed by uniform distribution between a comma b. That means it's take a constant value throughout the a and b, right? So can you tell me how can you find the fx of the these things? Okay, so this is again you have rectangle. So area will be what?
K into B minus A.
A into B minus A.
K into B minus
K
A.
into 1 upon B minus A.
No, K
Right?
into B minus A. Area.
Oh, yes. You are right. Sorry. It will be K into B minus A equal to 1.
Equal to 1.
Right? So my K will be 1 upon
B minus A. Correct. Yeah.
which is nothing but the CDF of the uniform distribution. Also, these things you can directly compute it by the integration. If you know integration, then you can directly compute it by the integration by how? See, A to B fx dx should be equal to 1. That means A to B I have K dx equal to 1, right? Similarly, I can take K as a outside, it will be A into B, 1 into dx equal to 1. Okay. So integration of 1 is nothing but the x, which is A to B equal to 1. So K into, put the limit, you will get B minus A equal to 1, which is again you will get K is equal to 1 upon B minus A, which is same as by the area formula. So you got the concept? Okay.
Yes.
So what is the uniform distribution? Suppose I'm saying x is follow uniform distribution A comma B, then my f of x is nothing but the 1 upon B minus A. A should be less than D, right? That means you can also say my x is lies between A to 0 otherwise. Okay. And there is a something standard uniform distribution, just a second form of this, which is nothing but the my fx will be 1 when my x will be like 0 and 1, 0 elsewhere or otherwise. So this is nothing but the standard uniform distribution, this is called. Okay, just you can say second form of this. Okay, I mean your when A is 0 and B is 1 distribution. Okay, so yeah. So I'm not going to derive the CDF formula for the uniform distribution, but you know how you can compute the CDF. Suppose I'm saying CDF of up to x, that means probability x is less or equal to x, right? That means I have to integrate A to x fx dx, right?
Yes.
Okay, that means A to x fx is what? For case of uniform 1 upon B minus A dx. If you will integrate, you will get fx as x minus A divided by B minus. This is the CDF for the uniform distribution case. Okay.
I just wanted to ask, instead of A, why didn't you write it as minus infinity?
Here.
Okay,
see, I said x is follow uniform A comma B. Then I have to find the f of x. So my x is upper limit is x, so lower limit is A.
Got it. Thank you. Yeah. Got
If
it.
it's not given something, then initially we took the, in general, we took as a minus x.
Okay. Got it.
Is it clear for everyone?
Yes.
Suppose in any question, I said x is follow uniform distribution A comma B. Okay. Then I said find the probability at least 2. Okay. Find the probability at least 2. Suppose this is x follow uniform minus 1 comma 3. Then how will you compute? Without using the integration, tell me.
So the thing is, you say 1 minus x less than 2. P of x less than 2. P of x less than x.
Okay.
So that is P of x less than 2 is nothing but the cumulative distribution function.
Yes, correct, Rangini. See, what is my f of x? Tells us nothing but the probability is x less or equal to x. In case of continuous, it does not matter, right? So, which is nothing but the x minus a divided by b minus a. What is this small x? Small x is this given value. My capital X is the random variable, and a is the lower limit of the uniform distribution, b is the upper limit of the uniform distribution. I said my x is follow uniform distribution minus 1 comma 3. Then tell me the probability of at least 2. Okay, that means probability of x greater or equal to 2. Suppose you do not know integration, then you can use the CDF formula directly. See, in the week 12, if you memorize 3 to 4 formula, then you will be able to solve the question in an easy way. You do not need to use the integration. Okay, so here I can write 1 minus probability x is less than 2. Okay, so this thing is same as f of 2. Now 1 minus f of 2 is what? This is my x, small x. So small x means 2 minus a is what? Lower limit, that is minus 1 minus 1 divided by 3. I mean b means 3 minus a is minus 1. Okay, see, minus is already there in the formula, but my a is already in my. Okay, so here I can compute 1 minus, it will be 2 plus 1 divided by 3 plus 1. It will be 1 minus 3 by 1 minus 3 by 4, which is it clear for everyone? Is it okay for everyone? If any question, suppose I ask, tell me probability of at most 3. That means x is less or equal to 3. Direct apply the formula f of 3. That means 3 minus a divided by b minus a. Is it clear for everyone? See, here your value is 1, right? That means what? Your x was uniform minus 1 comma 3. That means you did the integration up to 3, which is 1.
Yes, correct.
Is it clear till this point? Similarly, see, I'm not going to do the derivation. You can do the expectation, but you for the lecture video you can memorize the formula. Expectation of x, for in case of uniform distribution is what? A plus b by 2, and variance of x in case of uniform distribution is nothing but the b minus a whole square by 12. Okay, so yes, so just let's take, suppose my x is follow uniform a to b and a is less than b, then what will be the CDF for uniform distribution? 1 upon b minus a. My x will lie between a and b, 0 otherwise. So this is the my CDF. What will be the my this is the PDF. What will be my CDF? Is nothing but probability x is less or equal to x. This is this value will be given to you. Okay, probability x is equal to x is nothing but the x minus a divided by b minus a. This x same as the okay. Now okay, and what is the expectation of x in case of uniform distribution? A plus b by 2. And what is the variance in case of uniform distribution? B minus a whole square divided by 12. So is it clear for everyone? So you can memorize this formula. If you remember this formula, then you can in the easy way you can solve the question. So this collected formula you can take a screenshot or you can write it down as well. It's on up to you. Okay, you have taken it. So far, anybody have any doubt?
No. Sir, are you done with your, weekly classes? I have certain general questions to ask.
No, I think one topic is left, that is exponential distribution. So after covering that topic, we will discuss. Is that okay? Till this point, uniform distribution, is it clear for everyone? Yeah, if you are done, then you can discuss. Okay. See, there is another distribution which is called the exponential distribution. Okay. By the word exponential, you are able to understand exponentially decreasing kind of things, right? Something graph of exponential is kind of these things for different variables. Okay. So a random variable x is said to follow the exponential distribution when it has PDF fx as lambda into e raised to power minus lambda x when x is greater or equal to 0, and your lambda should be greater than 0 as well. It will take 0 value otherwise in otherwise case. Okay, so that means your PDF for exponential distribution is nothing but the lambda into e raised to power minus lambda is there. Okay, that is the PDF of a exponential distribution. Similarly, you can compute the CDF, that is probability x is less or equal to x. So tell me from which limits we can integrate. From which limit to which limit we can integrate?
0 to infinity.
0 to x.
0 to x, because lower limit is c.
Correct.
Okay.
Correct.
Lower limit is 0 and upper limit is x. Okay. So it will be fx dx. That means 0 to x lambda e raised to power minus lambda x dx. So if you integrate, then you will get the value as 1 minus e raised to power minus lambda x. This is the CDF of a exponential distribution. That means, suppose I ask, question fx is probability x is less or equal to x 1 minus e raised to power minus lambda x. Okay, so what will be the probability x is greater than x?
Sorry.
Okay, this thing probability x is less or equal to x is given to you. I'm asking, tell me about the value of probability x is greater than x.
1 minus 1 minus
E
x.
of E of minus e raised to the power
1
of
minus
x.
probability of x is less or equal to x.
Yes.
Yeah.
Because what? Probability of x is less or equal to x plus probability of x is greater than x is what? 1. Adding all the probabilities is equal to 1, right? So I can write it. So 1 minus, I know this thing. So 1 minus e raised to power minus lambda times x. So I can write 1 minus 1 plus e raised to power minus lambda x. 1 will get cancelled out. So e raised to power minus lambda x. So you can also memorize, or you can also you can do you can solve this, but you have to remember this equation. I mean, if you remember this value, then you can solve questions related to the exponential distribution. And similarly, if you remember the CDF of uniform distribution, then you can also use that. Okay.
Prashant,
So
sorry,
tell me. Yeah, yes, please.
In which lecture can I find this? I have not gone through this one.
That continuous things.
Yeah, this one.
12.1 or 12.1a.
Thank you.
Okay, starting of the week 12. Okay. Yeah, please watch that. Your doubt will be clear. Meanwhile, you can understand by the continuous things, because you have to do the. I mean, you have to find the region between A and B, right? It can be A to B, inclusive or exclusive, right? Because you cannot differentiate in case of continuous. Okay. So similarly, expectation of x. I mean, expectation of x in case of exponential distribution is what? X fx dx. If you will integrate, then you will get lambda. 1 by lambda. This is the expectation of exponential random variable, and variance is what? Anybody? One by lambda square. Okay. So see, derivation of these formulas is not in the scope of this foundational level course. By the things you can memorize the things and you can remember the things. That means if my x is follow exponential distribution with parameter lambda, then PDF will be lambda times e raised to power minus lambda x. My x will be greater or equal to 0 and lambda is the greater than 0. This is the PDF. CDF will be probability x is less or equal to x is nothing but the 1 minus e raised to power minus lambda times x. So similarly, if I know this quantity, then I can compute this quantity, which is e raised to power minus lambda x. And expectation of x will be lambda, sorry, 1 by lambda, and variance of x will be 1 by lambda square. This is the all formula for the exponential distribution. So you can take a screenshot or you can write it down. Then we will proceed further. I mean, I will give some, we will consider some examples. I mean, is it clear? CDF expectation and variance to all of you?
Yes.
So you are write it down, you took the screenshot. Okay. Suppose a question is there, I'm taking a question.
So Prashant, there is nothing related to normal distribution into
No, there is. Yeah, normal distribution is not covered in the stats 1 course. Okay. Okay. Initially it was, I mean, the previous terms it was, but now it's not. Normal distribution is covered in the statistics 2. Okay.
Okay.
I mean,
Fine.
in stats 1, only uniform and exponential is there, and we will not give the any question which is related to integration. I mean, there where you need to use the integration. No, there will not be any question related to integration, because you can you have to use just directly formulas, CDF and all things. That's why I said you can take a screenshot and all this, or you can memorize the CDF formula for case of exponential distribution and for case of uniform distribution as well. Okay.
Yeah.
So that is the things till now. Yeah. So suppose tell me, I'm taking an example. Suppose a length of phone call in on an average follow exponential distribution, and length of a phone call on an average is okay, on an average is suppose 10 minutes. Okay. I'm saying length of a phone call is follow exponential distribution, and on an average length of a call is 10 minutes. Then what will be the probability? Suppose it's something at a telephone booth. It's a case of at a telephone booth. So what will be the probability call will be more than 9 minutes? Or you can say, I'm taking at least 5 minutes. Are you getting my question? I'm saying length of a phone call follow exponential distribution, and on an average length of a call is 10 minutes. Then what will be the probability at least probability for at least 5 minutes call? So tell me, how will you approach?
E of x is equal to 10, from which we will
Sorry?
be able to find lambda. E of x is equal to 10, and from which we will
Yes,
be able to find the
Sivakumar.
lambda.
Yes, that is the correct approach. Because sometimes student will take directly lambda is equal to 10. No, I said on an average length of the phone call is 10 minutes. That means expectation of x is given to me, which is 1 by lambda, which is 10. So my lambda will be 1 by 10, which is lambda is equal to 0.1. Question is at least 5 minutes. That means it will be x is greater or equal to 5. So I can do 1 minus probability x is less or equal to 5. Right? I can do 1 minus, I know these things, 1 minus e raised to power minus lambda times x. So I can do 1 minus e raised to power minus lambda 0.1, x is 5. So you can compute this quantity. I mean, this one will get cancelled out. You have to compute only this quantity. Is it clear for everyone? Suppose in any case, that, instead of by giving given the value of lambda, it is given the some average and all things, then you will be able to compute the required probability whatever in the question. I mean, is it clear
Shouldn't
to?
it be 1 minus probability of x less than 5?
Yeah, will not be matter. It will not matter in case of continuous result.
Okay.
That is
Okay.
yeah.
Because at one point it is 0.
Yeah, at a singleton point, it will be 0. Yeah, that is the another. Yeah, that is the correct point. Madhu, you can take it as at a singleton point, probability will be 0, right? So you can relate to this one as. So is it clear how you can solve this question in case of suppose in case of exponential, I can say variance of the length of phone call is 100 minutes. Okay. Then you do not about lambda, but you know about the variance of exponential distribution, which is 1 by lambda square, which is 100. So from here you can compute the lambda 1 by 100. Are you getting my point? And after that you can proceed further whatever the question is asked. Is it clear for everyone? Is it okay for everyone?
Yes.
Yes.
Yeah, just we'll do a quick revision for the case of uniform and okay. So tell me, what will be the PDF of uniform distribution?
Integral A to B.
No, just PDF. Just tell me the PDF. Final value. 1 upon B minus A, right? Okay. What is the CDF? X minus A divided by
B minus A.
B minus A. What is the expectation value? Expected value?
A plus B
A plus
B by 2.
Yes. What is the variance?
B minus A the whole square by 12.
Okay. There might be a question in the there may be a question like expectation is given to you, variance is given to you, then find the value of A and B. Then you can easily find, right? Okay. For the in case of exponential distribution with parameter lambda should be greater than 0. What is the PDF? Lambda times e raised to power minus lambda x. X should be greater or equal to 0. Lambda should be greater than 0. This limit you have to remember. What is the CDF in case of exponential distribution? One minus e raised to power minus lambda times x.
X.
Okay. Similarly, you can find probability x is greater than x, e raised to power minus lambda x.
X.
Okay. What is the expectation of x in case of exponential distribution? 1 by
Lambda.
the variance of x will be 1 by
lambda square.
Okay. That's all about up to week 12. Okay, so from my side, I think I have covered the concepts. Okay, do you want to take the screenshot of last page that so I can is my screen visible?
No.
One second, yes. Now it's visible, right? So you can take a screenshot of these formulas. I mean, all the formulas together.
Sir, is it possible to please share this whole notepad file?
Notepad, okay. This whole things you
Yes, sir.
after the session will you able to understood because there is some missing kind of things. I do not have any problem. We will share it. Further, say
Please
slides
share,
of
we'll
the
manage.
yeah. Okay. We'll share. Okay. There slides of the week 1 to week 4 is also shared with you, right? Okay, so you can take a screenshot if you took taken it, then I can stop my share. You're taken?
Yes.
Okay, yeah. Okay, so yes, that's all my side. Hope you will perform well in the exam. That's best wishes from my
Sir,
side.
this will be the last session.
Yes, this is the last session. Because we have covered all the lecture
Okay.
between up to be, and I think
Prashant?
next.
Okay.
Yeah,
Okay.
yes, please.
Yeah, Prashant, I want to know on an average, generally, how many people are there in the class after qualifying?
After qualifying,
Generally, how many people are there in every batch? How many? What is your observation?
it's you can say it's, I mean, normally results is around total people around 60. I mean, maximum 60% is the result.
Okay.
60 to 65. Sometimes
Okay.
can goes above 60, but it's normally on an average we have observed. So yes, and
Sir,
in the
I have
exam
a
paper, sorry.
Yeah, sorry, sir. Please go on.
Yeah,
I
I'm
have a
saying in
doubt.
the.
I'll talk after you explain this. Yeah.
Yeah, okay. Please ask. Please ask.
No, we can use the scientific calculator, right? Is there any place where we can see how the mock, I mean, we are going to attend this online exam, right? How it will be, is there any mock kind of thing like, and how
On the
can we use the
TCS,
scientific
yeah.
calculator while we are attempting the exam?
Okay. On the TCS software, okay, TCS, there will
Okay.
be some scientific calculator, okay, on which you can perform a calculation in a easy way.
I
Okay,
think
can
you
we
can
use
go to
keyboards
the
to type the
Google and
numbers or?
just search the TCS calculator. It will be.
Yes. Or
No, what I'm asking is when we are attending the question in the screen, there will be only that screen only will be active, right? No other screens will be able to swap it. So in that case, from where we'll be able to pick up the scientific calculator like that, I'm asking. So because I have no idea how the online exam will be, like the
okay.
screen,
See,
whether
scientific
it will be.
calculator. I think, yeah, scientific calculator. It will be. It will be up at the upper side of your screen. Let me share
So
my
is there
screen.
any sample screen how the exam will be conducted? I mean, how the
I do
online
not
exam
have.
screen appears like that?
I'm
Is
not
there
sure about that, Samili, but I can give you idea. I'm not sure about it's exact that one, but is my screen is visible? It might be something kind of this one. Okay. Suppose
Okay.
question is there, you can click on your calculator, you will get your. I mean,
So we can
this
use
top
the
right.
keyboard numbers and all, right, to
Yes,
calculate
you can use keyboard numbers, but you
keyboard
cannot
numbers.
change
Okay.
the tab. Okay. But okay.
That's what I'm asking. So how we will
Yeah.
use?
Suppose you have question, you will have some as questions. You can scroll or change that, but calculator will be there, like kind of this up
Okay.
top
It will
right
always
corner.
be available.
Yeah, it will be always available. It will
Okay.
not make any problem in solving during the calculation.
Okay, sir. Okay. Thank you so much,
Okay,
sir.
yeah. Okay. So hope you will be. So it's best wishes from our side. Just give your best, and thanks. 7th of August, you have exam, right?
Yeah.
Yes, sir.
Prashant, generally after the
Sir,
exam, how
quickly.
much time we get the result?
2 to 3 days. More.
Acha, so we'll be notified by email, is it?
Yeah. You will be notified. You will be notified about the result. Right?
Okay.
You will get about notification your result and all.
Okay.
Okay. Yeah.
I think there is a login already created. There also, I think you will get it.
Yeah. And
Dashboard?
Email dashboard.
yeah.
There is a dashboard into Gmail. There is a link related to qualifier exam results. You will get over there.
Okay. And such type of things you can ask with support team as I mean, they are uh, they are handled such type of. Okay, anybody have any doubt
Okay.
or if not,
Prashant,
then we can.
yeah,
Yes.
Prashant, quickly in terms of preparation, sorry to say, like so far I've just gone only through 4 weeks video. I'm kind of worried now. Like, is there any way that we can quickly kind of crash course, or any way we can skip and go through sessions to cover the rest of 8 weeks that's left for me? And that's one thing. And if I jump from now after attending this session, I'm just thinking of going over directly to 8 to 12 chapter. So if I jump after from week 8 to would it make sense, or it has to be in a sequential order?
No, I think sequential order will be better because see, In the case of week one, see, in the week one, you will there is concept of scales of measurement, categorical data, numerical data. Okay. In week two, plots for the charts for the categorical data. In week three, dealing with the numerical data. In week four, association between categorical data and numerical data, right? And 5, 6, something what? Permutation combination. In week seven, we have studied basic concepts about probabilities. In week eight, uh, I mean, uh, advance of probability, that means Bayes theorems, independence rule, multiplication rule. So in week 9 we have studied. So today we have studied just started with what is the random variable x. After that we have covered the PMF, we have covered the CDF. Okay, about the CDF of random variable, probability of random variable, PMF of a random variable. Then we have saw the expectation, variance, then Bernoulli trial, then combination of n Bernoulli independent Bernoulli trials will form the binomial random variable. So Bernoulli is related to the binomial. So till the binomial we have covered the discrete about the distributions of the discrete random variable. Come to the week 12, we have covered the continuous random variables. So things are related, and for those things you can rewatch the recording of WebEx session which we have taken. Okay, so you can rewatch because
the video
in
list
this
is
session,
very huge.
yeah, yeah, I agree. Syllabus is huge, but it's
So-
on your
So,
based on you
Prashant,
how you are.
basically, I think if you have something kind of summary document for maybe all the 12 weeks in terms of the formulas, etc., I think that will be helpful.
Okay, Naresh, I do not have such type of all the summary. I mean, up to week 12. So that's why in the between session I told to all of you, like,
Okay,
you can take a screenshot of kind of things, because we did not have like such a means collection of whole things. So that's why we have shared the notes of week 1 to week 4. These notes I will share to you. Okay, so you can see in this week 12 major things is uniform, exponential, and all things. I mean CDF and all things. Okay. And in week 11 you can major focus on binomial and all things. You can just a suggestion or hint, whatever you can say. So such type of things is there. Is that okay? Yes. Yeah.
Sorry. This might not be a question
Yeah,
to you.
one by
but,
one. One by one.
Yeah. Yeah, please go ahead, Amit.
No, I was asking the presentation, the slides that Professor Usha Mohan was using in these videos. Are those available by any chance anywhere? Because
Okay.
those would be helpful to quickly go.
Okay, Amit, we'll check it's available, then we'll share with all of you. Okay.
Yeah, because that will be easier for revision.
Yeah. Yes, Nisi.
Actually, I have a question that will this lecture be updated on the YouTube, because the previous 2 sessions have been uploaded on YouTube. So will this session be also uploaded on YouTube?
Previous to WebEx, right? I mean, recording of the WebEx session, week 1 to week
Yes,
4,
yes,
and
yes.
then
That's are uploaded.
yeah. Okay, no worry about that.
But that were uploaded just 2 days back. So can you ask the team or forum to like upload it quickly, as I wasn't able to go through today's session.
Okay.
And one more thing, that they haven't uploaded the max sessions, like max 1 sessions. So can you just ask them to upload that too?
Okay, YouTube record all the session of maths. I mean,
Yes, all the
about
sessions of max. They haven't uploaded any session of max. They have actually uploaded Python sessions also, but there is no session of max uploaded on YouTube.
Okay, and previous recording of previous 2 session is uploaded for the stats one. I mean,
Yeah, for stats and for Python, previous 2 sessions, like last to last week sessions are uploaded for Python and for stats, but there is no no videos or no sessions have been uploaded for max. And this week, it's like for this week they have not uploaded any of the sessions, neither Python
Okay.
or
Okay,
not.
we'll ask with the team and we'll update about it. Okay. Things will
How
be
to
Yeah,
get link, Prashant? But those online videos.
that's on YouTube. Like that.
That's
That's
on
on
YouTube.
the yeah BSc diploma. BSc degree program. IIT Madras BSc degree program. That's on their YouTube channel.
Nisi, you can share the link on chat so that
Oh, just
everyone
a
can get.
second.
Yeah,
Yeah, just a second.
that will be convenient for everyone.
Yeah,
Prashant sir,
I
this is
will
a question about do we have any previous solved questions of previous years or last, because it's a program which is running from Stella.
Don't
By
think
any chance?
so. I don't think so about that. Things which will be available, will share with you. Okay. Today's slides, which I discussed throughout the session, we'll discuss with you. And rest of the things, Nisi has mentioned that I will ask with the team. Okay. And we'll talk about all the things. Okay. The things which we can provide, we'll provide to all. Right.
Thank you so much, Prashant. I learned a lot of new things. Thank you so much. Thank you so much. You really teach very well.
Okay, thank you. Thanks for the
Thank you so
compliment.
much, Prashant. Thank you. Bye.
Okay, Nisi have
Thanks.
updated
Thanks,
the
Prashant.
thing.
just a second. I'm sharing the link.
Yeah, okay, yeah. Please share this so that everyone can do. Okay, yeah, she has shared.
So
Okay,
this is one
so
of the links, and here you can find the other three
yeah,
videos. Python.
yes.
Yeah.
Okay, then thank you everyone. Bye. Hope you got your concept.
Hope
You guys have covered the lectures video, and someone
you got
has
the concepts of permutation, combination, and addition rule of
someone has okay, please stop that YouTube lecture. Someone has started. Okay, then bye everyone. Hope you have got the concept. Yeah, thanks.
Thank you. All the best, everybody.
Okay, all the best for everyone.
Thank you.
Just give your thanks everyone. Bye. All the best for your
Bye.
jam.
Thank you.
Yeah, thanks.
All the best, everyone. Thank you.